Hi chemists, my name is Kim and our learning goals for this video are to define a bunch of vocabulary terms related to electrochemistry. So electrochemical cell, chemical versus electrical energy, cathode, anode, and battery, along with voltaic and electrolytic cell. We also will describe the difference between spontaneous or voltaic and non-spontaneous or electrolytic cells in terms of energy, and we will think about whether a voltaic cell or an electrolytic cell is best suited to complete a given task and explain our choice. Finally, we will explain why chemists love to say red cat and ox when talking about electrochemical cells. I promise you there's a reason. Let's get to it. Let's start by defining electrochemical cell. Fortunately, it's kind of right there in the word. Electrochemical. Electrochemical cells are devices that convert electrical energy into chemical energy, or vice versa, chemical energy into electrical energy. Now, when we say electrical energy, what we mean is moving electrons, or electricity, as we often think about it. And when we say chemical energy, we mean the energy that exists when there is potential for a later chemical reaction to release energy. So as we are converting between electrical and chemical energy, we are thinking about which direction we're going, right? That's going to be important as we consider electrochemical cells in a moment. In all electrochemical cells, no matter which direction they are converting energy, there is always a cathode and an anode. The cathode is the location where reduction takes place, because in an electrochemical cell, a redox reaction is occurring. So at the cathode, a reduction reaction is happening, and at the anode, an oxidation reaction is happening. Electrons are traveling around the cell. We can remember these two parts of an electrochemical cell by using the memory device red cat and ox. Red cat stands for reduction at the cathode, and ox stands for the anode being oxidation. Strange, but it works pretty well to remember those two parts of the electrochemical cell. And those are literally just the two physical regions where those two processes are taking place. There are two main types of electrochemical cells because there are kind of two directions we can think about energy converting. We can think about chemical energy being used to generate electricity. So we can think about chemicals reacting and becoming electricity. This occurs when a spontaneous chemical redox reaction is converted into electrical energy. The input for this would be chemical energy. The output would be electrical energy. Now, we could also see this going the opposite way. Maybe we actually could use electricity to make a redox reaction happen. So we could also take electrical energy and use it to create a compound, a chemical that maybe in the future could be used to do another reaction and release energy. So in this case, I would be putting in electrical energy and I would be getting out chemical energy that I could maybe use later. So I could go chemical energy to electrical energy, generating electricity, or I could use electricity to make a chemical reaction happen and generate chemical energy that I could potentially use for later. These are kind of the two ways that electrochemical cells could go. We call electrochemical cells that generate electricity voltaic cells. And we call electrochemical cells that require electricity to begin. We actually have to put electricity or energy into them. We call those electrolytic cells. The word electrolytic makes sense in this context. Electricity. Lytic means to split. So we think about the need to put energy into the electrolytic system to actually make the reaction occur. So voltaic cells, if we're thinking about like a Venn diagram, I always like a Venn diagram to organize my two different processes. If we think about voltaic cells and electrolytic cells, it's useful to remember what they have in common. They're both a type of electrochemical cell, and they both involve redox reactions. In a voltaic cell, chemical energy is being converted into electrical energy. The redox reaction that's involved occurs spontaneously. And voltaic cells are often used to generate electricity. So for example, in batteries, A voltaic cell is used because the redox reaction occurring spontaneously will convert chemical energy into electrical energy. On the other hand, electrolytic cells are taking an electrical energy input and using that to make a reaction happen that wouldn't otherwise occur, a reaction that would not occur spontaneously. So electricity is needed to start the reaction. This is used in most often a process like electroplating, trying to take one metal and coat it onto the surface of another metal. You'd want to think about reasons to use electrolytic cells where you actually need the reaction as part of your intended product. Whereas when you're thinking about a voltaic cell, that is where you would want to be getting electricity as an output. The other thing that both voltaic cells and electrolytic cells have in common is that they both involve reduction happening at the cathode and oxidation happening at the anode. So that's another thing that they both have in common. Let's try a practice problem. During the operation of a voltaic cell, the cell produces, is it electrical energy spontaneously, chemical energy spontaneously, electrical energy non-spontaneously, or chemical energy non-spontaneously? Think about it, choose an option, and pause the video if you want more time to think. So the way that I like to remember this is that electrolytic cells have the word electricity in them. Electrolytic cells are cells that require you to put in electricity. So in electrolytic cells, you start with electrical energy and you produce chemical energy. It's the opposite in a voltaic cell. In a voltaic cell, we are happening spontaneously and we are making electrical energy. So in an electrolytic cell, you have to start with electrical energy and you would end up with chemical energy. The process would be not spontaneous. In a voltaic cell, the cell is going to produce electrical energy spontaneously. Let's look at another one. An operating voltaic cell has magnesium and silver electrodes. The cell and the ionic equation representing the reaction that occurs in the cell are shown below. Explain in terms of electrical energy how electrolysis reactions differ from voltaic cell reactions. There are a couple of different ways that you could have thought about answering this question, but you wanted to make sure you were explaining in terms of electrical energy. So two ways you could phrase this would be electrolysis reactions, which are what is happening in an electrolytic cell, convert electrical energy into chemical energy, while voltaic cells do the opposite. They convert chemical energy into electrical energy. Another way you could say it is electrolysis reactions require electrical energy to start, while voltaic cell reactions produce electrical energy. Let's think about how this kind of relates to the real world. An oversimplification, but still a fun game. Let's imagine you needed to design a device to charge your cell phone. Would you rather design a device based on voltaic cells or electrolytic cells? What do you think? Give you about 5 seconds here. Pause if you want to think some more. If you wanted to charge your phone, you would need electrical energy. So you're going to need a voltaic cell. You're going to want to be producing or generating electrical energy from chemical energy. So you're going to want that voltaic cell in this instance. Let's think about what if we needed to design a device that will allow us to break apart water and form hydrogen gas and oxygen gas. So that probably doesn't occur spontaneously. Otherwise, we would see water just kind of chemically decomposing everywhere. This would probably need an electrolytic cell. It's going to require us to put energy in, and it actually is a redox reaction because we're starting off with hydrogen and oxygen gas on their own and we're creating water. So we are going to be reducing oxygen and oxidizing hydrogen in the process. And we're going to need to put energy in here. So we're getting chemical energy out in the form of hydrogen gas and oxygen gas, but we are putting in electrical energy to make this happen. The electrolysis reaction would split the water apart. That's where that word comes from. Let's pretend we need to design a device that will allow us to electroplate gold onto a zinc bracelet. The keyword here is electroplate. So electroplating is a process that requires an input of energy, electricity. So this would probably be an electrolytic cell because I need to put electricity in order to make the reaction occur. And then finally, let's say we need to design a device that will allow us to light a light bulb. This would be a voltaic cell. We need electricity to light a light bulb. So I would need a voltaic cell to be generating electrical energy in order to light that light bulb. Let's return to our learning goals and see how we feel. Hopefully you were able to take in some of the vocabulary we talked about today, especially red cat and anox, very useful. And you have a bit of an idea of the difference between voltaic cells and electrolytic cells. Remember, batteries are just voltaic cells that are arranged together to provide a power source. Awesome job today.